Well, hello. I see you're back now for Newton's Toy Box. Activity number 2, gravity and balance. Some of you are starting with activity 2. That's okay. You're going to get activity 1 eventually. Some of you have already experienced activity 1 or even activity 3. Again, that's okay. All of these things are tied together. So activity 2, gravity and balance. You will be observing and identifying the force that makes objects fall. We're going to measure the strength of the force that makes those objects fall, and we're going to compare some different types of forces. Vocabulary. In this activity, gravity obviously is our first vocabulary word to work on, and it is a force that pulls all objects towards the center of the earth. There's also something called a gravity support force, a Newton, measured with the capital N, and pound, which we label with a lowercase l and a lowercase b. And then we have weight. For balanced forces, that is when an object is not moving or it's stationary. So if you take a look at my lovely little girl sitting in the chair, she's sitting on the chair and she's not moving up or down. That's because she is putting a force down on the chair, but the chair is also pushing back up. If we have unbalanced forces, that's where objects are moving in the direction of the force. So here's my happy little baseball player. He's throwing his baseball up in the air. Because the ball is moving, that means the force is greater in an upward direction. There's also a force that's pulling it down, but right now, the one going up is greater than the one going down. Some of you might remember the test question on our practice test about the pencil, and it showed 4 different pictures of Susan pushing on the pencil, and it showed her pushing with her finger in this direction, but no force on the pencil. If that were happening, then that pencil would be moving. This one shows the pencil pushing back on Susan. If Susan's not pushing but the pencil's pushing back, that would move her entire hand. Highly unlikely. In this particular picture, it shows a bigger force of Susan's hand going against a smaller force of the pencil. In this case, the pencil would move to the right. In this last picture, which was the correct answer, by the way, this shows the equal force of a pencil balanced against the equal force of Susan's finger. And if they're both pushing with the same amount of force, then that pencil won't move. Now, I know many of you have tried to put the pencil on the table and push it with an equal force of the pencil not moving. It's kind of hard to do, but the way we show that force is by using the arrows. If we have a greater force, then we have a bigger arrow pointing in the direction of the movement. One of the tools that you're going to be using in this activity and activity 3 is something called a spring scale. We have 2 different kinds of spring scales. We have a blue spring scale, which, by the way, you hold with the loop up at the top and the hook down at the bottom. And you'll notice as I pull down, you'll see something inside the tube also moving down. We also have the yellow spring scale, and as we pull down, it moves down, but not quite as easy. Now, from my picture here, you can see that our spring scale is measured in the force of newtons. 0.25 is the first mark, 0.50 is the second mark, 0.75 is the third mark, and 1.00 is the fourth mark. It is very, very important that you always make sure your spring scale is zeroed without anything attached on the hook. To be able to zero your spring scale, you have to hold it by the top loop and see where that little blue bar falls. Now in this case, you might be able to see that the mark for newtons is up here where my finger is, but the blue dial that shows 0 is here down below that mark. In order to balance that, we have to turn this little nut right here at the top. If you turn it one direction, you'll see that the spring kind of tightens up a little bit and it pulls that blue disc up. Now, I don't know if you can see this or not, but you can now see that the blue disc is lined up with 0. Just like a balance that we use to measure mass, we have to make sure our spring scale is also zeroed. Once you get it to 0, then you're going to take the object that you have to measure, which in this case is a little wooden ball, and you're going to place it into a bag like this one, and you're going to very loosely tie it into a loop here at the top. You'll hang this on the hook like so. And then holding only the top part, making sure that the bag and the ball, nothing is touching any other surfaces, you can now see that the disc has dropped and it's measuring a mass of 0.25 newtons. Now, the difference between the blue scale and the yellow scale is how much you can measure. The blue scale is used for objects with a lower mass. It will only measure up to 2.5 newtons. The yellow scale has a stronger spring in the middle of it, and it will measure up to 50 newtons. So obviously we will use this to measure greater masses. Conversion. Do you remember that conversion you did with Mrs. Rulin a few weeks ago? We're coming back to it. This is where you're going to use it a lot. We're going to start simple with just basic one-step conversion. So I want you to start with 50 pounds. We're going to put it over a 1, and we're going to multiply by 4.448 newtons over 1 pound. Why? Well, because I know that 1 pound is equal to 4.448 newtons. Why did I put the newtons on the top? Well, a couple of reasons. I want to know how many newtons, so I want newtons to be on the top when I get finished. Also, I want my pounds to cancel out. So if I have 50 pounds on the top, I have to put my label of pounds on the bottom. Now at this point, we're going to do a little bit of canceling. So, pounds are on the bottom here, pounds are on the top here, and now we're going to multiply. So you're going to pick up your handy dandy calculator, which will be available at your lab stations, and you're going to multiply 50 times 4.448. And that tells us that we have 222.4 newtons. Over 1 on the bottom. Do you remember that conversion stuff? If not, that's okay. We're going to practice it some more as we go through our lesson. All right, the last thing that you have to do before you come to class tomorrow to do your activity is this. I would like for you to complete a type 1 writing on what forces are acting on you at this moment. Think about it. Are you sitting? Are you standing? What's keeping you there? Are you moving or are you staying stationary? Make sure you get this done so that you can put it in your science notebook. You can also draw pictures, kind of like I did on the couple of boards before. Those pictures might help you explain your ideas a little bit better. Well, good luck, and we'll see you tomorrow.